Okay, good day. I trust that you are well. The purpose for today's lesson is to look at the Theorem of Pythagoras. Now, Pythagoras was a man who lived around 500 BC, and he came up with a very important theorem that we use today, and that is known as the Theorem of Pythagoras. So it's named after him. So it has to do with the right angle triangle. So I constructed a right angle triangle as seen below. And you can see that when I measure angle ABC, angle B, this angle, is equal to 90 degrees. So this is a right angle triangle that I constructed with Sketchpad. Now, the theorem of Pythagoras has to do with the area. So let's say I construct a square on with the length of AC. So there's a square on AC, there's also a square on BC, and there's a square on AB, right? So Pythagoras states that the area of the square, here, this invisible square, and I'll construct it later on if there's time, plus the area of the square that's constructed with the length of BC is equal to the area of the large square of AC. Now AC is the largest square because AC is what we call the hypotenuse of the right angle triangle. So this angle, angle ABC, right here, the side that is opposite the 90 degrees angle is called the hypotenuse. Very important. So AC is the hypotenuse. So because area is calculated as the area of a square is the side square, what I can actually prove is that AB squared, that's the area of the square, plus BC squared, the area of this square, is equal to AC squared, which is the area of the large square. That is the theorem of Pythagoras. Now, many learners, they make the mistake and say that the theorem of Pythagoras is AB plus BC, which is equal to AC, which is absolutely incorrect. The theorem of Pythagoras is not that. It has to do with the square of the sides. So the theorem of Pythagoras states that the hypotenuse squared is equal to the sum of the squares of the other two sides. And I have Sketchpad open because I want to quickly prove that to you. So if I can prove that AC squared is equal to AB squared plus BC squared, theorem of Pythagoras is true. And remember, this is a right angle triangle. So let's measure the lengths of these sides, right? So I can see that AC is 6.07 centimeters. AB, let's measure that distance, it's 5 centimeters. And BC, let's measure that. BC is 3.44 centimeters. Now the theorem of Pythagoras states that the hypotenuse squared is equal to the sum of the square of the other two sides. So let's take our calculator and let's calculate AC squared. So AC squared is equal to 36.84 centimeters squared. Now I'm going to take AB squared plus BC squared. So let's take our calculators again. So we have, let me use brackets, right? So I have AB squared, right, plus, right, plus brackets, BC squared, right? And what does that give me? What do you notice? That AB squared plus BC squared, which is 36.84, is the same as AC squared, which is also 36.84 centimeters squared. This is the theorem of Pythagoras. The hypotenuse squared is equal to the sum of the square of the other two sides. So let us look at some examples of where we can apply the theorem of Pythagoras, right? So let's open some examples now. Okay, so now we have this problem in front of us. We are given triangle ABC, and I know that this is a right angle triangle because there's a small block here, and this block indicates that AB is perpendicular to BC, meaning that this angle that's formed here is 90 degrees, right? So according to the theorem of Pythagoras, the hypotenuse squared is equal to the sum of the square of the other two sides, and we are required to find this length here, AC. So I can see that opposite 90 degrees, right, is the hypotenuse. So AC is the hypotenuse of the triangle, of the right angle triangle, right? So let's see what we can do. We know that the hypotenuse squared is equal to the sum of the square of the other two sides. So start off with what you wanted to find. So I have AC squared is equal to AB squared plus BC squared. And always give a reason for your statement. My reason is Theorem of Pythagoras. I like to abbreviate it as such, Theorem of Pythagoras, right? Now, AC, we do not know the length, so I'm going to drop that down as AC squared is equal to AB squared, so that's 4 centimeters squared. So in brackets, I have 4 squared plus BC squared, which is 3 squared. So AC squared is equal to 4 squared, which is 16, plus 3 squared, which is 9. And of course, if you want, you can actually put the units inside. So if I have centimeters, it's going to be 16 centimeters squared plus 9 centimeters squared. So AC squared is equal to 25 centimeters squared. Now, how do I get rid of the square? Now, the opposite of the square is the square root. So I need to square root both sides. And what number multiplied to itself gives me 25? Now, obviously, it will be 5. 5 times 5 gives me 25. But what about negative 5? Negative 5 times negative 5 also gives me positive 25. Do not forget, a negative multiplied by negative is a positive. However, if I take my ruler and I measure the distance of something, you'll never get a negative amount. So the length is always measured as a positive value. So when I square root, it's positive the square root and positive the square root of 25. So as I mentioned earlier, right, the square and the square root, they basically undo each other in a sense. So I'm left with AC is equal to the square root of 25, which is 5. And of course, now I can put my units centimeters squared. So my final answer is 5 centimeters squared. So that's the length of AC. And by the way, many learners make this very silly mistake. They tell me that the theorem of Pythagoras is 4 plus 3, which should give me the hypotenuse. No, that's not what the theorem of Pythagoras states. It says that AC squared. So 4 squared plus 3 squared gives me 5 squared. That's the theorem of Pythagoras. So let's look at another example where we are given the hypotenuse, right? However, in this case, we are not given the length of the other side. So let's see what we can do in that particular situation. So let me clear the screen. Okay, and let's clear the screen nicely. Yeah, right. So let's construct a right angle triangle very quickly. So I have a right angle triangle. How do I know it's right angle? Because it'll be given that this angle here is 90 degrees. Let's get this right. Right. And so let's say this is triangle DEF. I'm given the hypotenuse, which is, let's say, 13, and I'm given this EF value. Let's say that's 12 meters. Let's work in meters now, right? And we need to find the length of DE. So the question will state, find the length of DE, right? So whenever I look at a right angle triangle, the first thing I like to identify is, what is my hypotenuse? The hypotenuse is always opposite 90 degrees. So if you said it, that's correct. The hypotenuse will be the length DF, which is 13. Yeah, let's get that right. Which is 13 meters, right? That is my hypotenuse, right? Now DE, it's not the hypotenuse, and EF is also not the hypotenuse. So I can write my first statement as such. Let's write a first statement. I could say that I want to find DE, so let me start off with DE. DE squared plus EF squared is going to give me the hypotenuse squared, which is DF squared, right? That is the theorem of Pythagoras. Right? That is basically the theorem of Pythagoras. So dE, we do not know the length, so I can say that dE squared is equal to, now I'm going to take EF squared to the other side of the equation because I want to make dE the subject of the formula. So I have dF squared minus EF squared. Now you could have started off with this second line here. There's no need to show this line. You could have started off with this and then said dot 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 theorem of Pythagoras. It's perfectly fine. That dE squared is equal to 2 dF squared minus EF squared. Perfectly fine. Now let's calculate the value of dE. So we have dE squared is equal to 13 squared minus 12 squared. So dE squared is equal to 169, because please do not say that this is 26. 13 squared does not mean 13 times 2. 13 squared means 13 times 13 minus 12 times 12, which is 144, right? So now we calculate the difference. So dE squared is equal to 25, and again, to get rid of the square, I need the square root. So I square root the left hand side and I square root the right hand side. So my final answer is dE is equal to 5 meters, right? Very similar to the other example, but in this case we have to find the other side of the right angle triangle. So just to recap, what does the theorem of Pythagoras state? It states that the hypotenuse squared is equal to the sum of the square of the other two sides, right? Also, if the question asks you to leave your answer in the simplest third form, right? If they ask you to leave your answer in the simplest third form, you can just use your calculator and do not leave it as a decimal. Leave it with the simplest square root. If they ask you to round up to one decimal place, you press SD on your calculator and you can round up to one decimal place. If they ask you for two decimal places, press SD on your calculator and you round up to two decimal places. Right. So this basically summarizes the theorem of Pythagoras. Thank you for your time.